welcome back to the course on scientific computing using Matlab. So, we will continue from the previous lecture. In the previous lecture, we have started with the power series method. So, we will now continue with that method. So, in the previous one, we have discussed power method to find dominant eigenvalue and then eigenvector. Now, it was the iterative method. So, from the convergence rate, so the rate of convergence basically depends upon the proportion so that is lambda i's by the lambda 1, because lambda 1 was the dominant value and this lambda i's are all the other values. So, it depends upon what is the lambda i's by lambda 1, because if this value is smaller, then the factor, the power k will be much smaller. So, then it will converge to 0 faster. So, smaller the proportion lambda I by lambda 1 implies faster the rate of convergence. Otherwise, its rate of convergence is linear. So, power method has a rate of convergence that is linear. So, this is the way we are able to find that the dominant eigenvalue. Now, I will find out inverse power method. So, what is the inverse power method? Now, we know that if a x is equal to lambda x, where x is not equal to 0. So, lambda is the eigenvalue of this. Then from here, then assuming that a is non-singular, which implies I can pre-multiply by A inverse. So, I will get this value lambda A inverse x, and this will be identity matrix. From here I can write lambda A inverse x, and this can be written as A inverse x is 1 over lambda x, this one. So, now from here I can see that if lambda is the eigenvalue of matrix A, then 1 over lambda is the eigenvalue of the matrix A inverse with the same eigenvalue of A inverse, and this is the same eigenvector. So, the same eigenvector whatever the I have started with this one, 1 over lambda will be the eigenvalue corresponding to A inverse. So, this is the same eigenvector we are choosing. Now, you know that from the power method, so we know that using power method we are able to find dominant eigenvalue and eigenvector then if lambda is the dominant eigenvalue, then which implies 1 over lambda will be, so lambda is the dominant eigenvalue. So, this is the minimum eigenvalue. So, I can say that this is the least eigenvalue in magnitude. So, I am talking about the magnitude. Now suppose if lambda is the smallest or the least, is the least eigenvalue of matrix A, and that is n cross n, that is I write A x is equal to lambda x. So, this is the, now I am considering that this is the least eigenvalue, least or the minimum eigenvalue in magnitude. Of course, everything is in terms of magnitude. Then A inverse x will have 1 over lambda x, which implies that 1 over lambda is the dominant eigenvalue of the matrix A inverse. So, now from here I can say that now, so what is the inverse power method? So, inverse power method is that for any matrix, so this is for any matrix A, that is n cross n, such that A x is equal to lambda x, where lambda is the least eigenvalue in magnitude, the least eigenvalue of matrix A, then applying power method to A inverse is called inverse power method. Because we know that A inverse x will be 1 over lambda x. So, then it will be the dominant eigenvalue, and I can apply the power method to A inverse to find this value. So, from we are able to find 1 over lambda, then using this I can find this lambda, that was the least eigenvalue. So, now from here I can say that using power method and inverse power method, we are able to find dominant eigenvalue and least eigenvalues. And least eigenvalues. So, now we are able to find at least 2 eigenvalue, that is the dominant eigenvalue and the least eigenvalue, and the corresponding x will be same in both the cases. Now, suppose I have a matrix A n cross n, and suppose its eigenvalue is given like this one. This is the range of the eigenvalues. Suppose I have, so let us that we have a eigenvalues. So, this is suppose lambda 1, this is lambda 2, lambda 3, lambda 4, maybe I can choose this one. Lambda k plus 1 to lambda n. So, suppose I have these eigenvalues. Now, I am able to find, using the help of power method, I am able to find the least values and the highest value. So, this is my least and this is the dominant. So, I am able to find this and this. Now, what will happen if I want to find in between? Suppose I want to find this value, I want to find this value. So, I cannot use my power method or the inverse power method to find the values, eigenvalues in between the maximum and the minimum. So, now what I can do with this one? So, for this one there is another method, very important method, and that is called the shifted inverse power method. Shifted inverse power method. So, in this case what we will do? Suppose I take a alpha. So, let us I choose one alpha here, this value, and that is alpha. Now, what I do? I try to find the eigenvalue close to alpha. Okay. So, let us write this one. Assume that the matrix A n cross n has distinct eigenvalues. So, that is I call it lambda 1, lambda 2 up to lambda n. So, let us consider my lambda k. So, this one I want to find. Then a constant alpha can be chosen so that, so let us assume that now I can assume that this is my lambda 1, this is my lambda 2 and up to here lambda n. So, it is, suppose I taking the axis now. So, it is suppose x axis and y axis. So, this quantity is the largest one. So, this is the largest one, dominant, and this is the minimum. Now, from here then we consider alpha be chosen so that, now we have chosen alpha close enough to lambda k, which is we want to find. So, this one we want to find. Then a constant alpha is chosen such that I take 1 over lambda k minus alpha, okay, and that I call it mu 1. So, let us call it mu 1. So, let us take this as a mu 1. Then what will happen that then, so that this is the dominant eigenvalue of A minus alpha I inverse using power method, and then and then lambda k can be written as, so what we will get the lambda k, so I can take this one, so it will be 1 over mu 1 plus alpha. So, this will be my lambda k. So, I can find the lambda k from here, right. So, that is the, we are able to find my lambda k. So, that is a shifted inverse power method. So, what we are doing, basically we are choosing, suppose this is the place my lambda k is falling at this place. Now, what I do, I choose a number alpha close to lambda k, and then I will finding the value a minus alpha I inverse, and using this one I will finding the power method. So, power method will give the dominant eigenvalue of this. With the help of this, and I am able to find the lambda k. So, that is called the shifted inverse power method. Okay. So, what I am doing here is that, so this is the explanation. So, proof is there. I know that we know that if lambda is an eigenvalue of matrix A, then I can write as A x is equal to lambda x, where x is the corresponding eigenvector and x is not equal to 0. Now, I also know that what about A minus alpha I x, this one I want to find. So, this will be again A x minus alpha I x, and from here this will be equal to A x minus alpha x, and I also know that I x is equal to x and alpha I x is equal to alpha x. So, the matrix, any matrix alpha I, the constant matrix, has the eigenvalue alpha. So, from here I can cite that this one I can write as A x is equal to lambda x and minus alpha alpha x is equal to alpha x. So, from here I can write that alpha minus lambda minus alpha x. So, this can be written like this one, okay, because this should be a matrix. So, I should put always I here, and then from here I can choose this I here, and then lambda minus alpha. So, x I can now take from here. So, from here I can say that lambda minus alpha is an eigenvalue of A minus alpha I. So, this is the eigenvalue we are getting. So, now there is no need to write I here, because this is already a x is a vector. So, alpha x, and this I can write no problem alpha x. Now, from a lambda minus alpha and x. So, this is the eigenvalue of the matrix this. Now, from here I know that what about A minus, then A minus alpha I inverse, and from the previous knowledge we know that A minus alpha I inverse. So, this one can be written as this from here, x will be equal to 1 over lambda minus alpha x. So, that will be there. So, from here I can say that 1 over lambda minus alpha is an eigenvalue of A minus alpha I inverse. So, that is the eigenvalue. Now, what will happen? Now, I want to apply the power method to this one, this matrix. Now, we want to apply power method. To A minus alpha I A inverse. Now, the question is that I know that the power methods that gives me the dominant eigenvalue. So, it is going to give the dominant eigenvalue. Now, how we can say that this is the dominant eigenvalue? So, that is the question. So, in this case we want that now if alpha is close to lambda, okay, we are taking this as a real valued the eigenvalues. So, if alpha is close to lambda, then 1 over lambda minus alpha is very large. In fact, if I want to plot a graph for this one, so suppose this is my alpha. So, this is the value of, and this is suppose I take the, I just take the magnitude. Now, if you see that this value is going to be like this one, and this value is going, the figure of this is going to, because at 1 over alpha this is going to be infinity, otherwise the value is this one. So, this is the value of lambdas or 1 over these values. So, when the alpha is, so when the lambda is close to alpha, then this is going to be a value infinity, because when lambda is equal to infinity, and in that case otherwise if it is going to be away from this one, then this factor, this value will be less. So, in that case we can see that this is the graph we can say. Then using this one, so which implies that if we choose alpha close enough to the required eigenvalue, that is, suppose in this case it is what we have taken the lambda k. So, this is the lambda k I have chosen. Then 1 over lambda k minus alpha is will be the dominant eigenvalue. So, that will be the dominant eigenvalue. So, with the help of using power method, to A minus alpha I inverse, we are able to find 1 over lambda minus alpha. So, that is the lambda k I am taking. So, suppose this is equal to, I can call it the, what we called it, that is we are calling it mu 1. So, that is equal to the mu 1. So, this is the eigenvalue of this. So, from here I know that using from there I will get 1 over mu 1 will be lambda k minus alpha, and from here my lambda k will be 1 over mu 1 plus alpha. So, now I am able to find the lambda k, where lambda k is the eigenvalue of the matrix A in between. So, it may be in between any values. So, in fact, now I can apply this to any value, it may be a least value or the maximum value also, does not matter. So, in this case I can apply this method to find any value of the any eigenvalue. So, that is the So, this is the way we can define this one and we can find the eigenvalue. So, using this one, using this method that is called the shifted inverse method. So, using shifted inverse method, we are able to find all the eigenvalues of the matrix of a matrix that is A n cross n. So, not only we are able to find the least value or the dominant eigenvalue, but with the help of shifted inverse method we are able to find any eigenvalue. So, you choose the alpha that is close to any eigenvalue, and with the help of this shifted inverse method we will find that eigenvalue. So, that we will see that how we can use these methods to find the eigenvalues, and in the next lecture or maybe after that we will be able to write the Matlab code, and then we will do that how using the Matlab code we should be able to find the eigenvalues of any n cross n matrix. So, I think now we should stop here. So, today we have discussed continue with the power method, and then we have discussed the inverse power method, and the last one is the shifted inverse power method. So, using the shifted inverse power method we are able to find all the eigenvalues of the given matrix. So, in the next lecture we will continue with this one and we will discuss other topics. So, thanks for watching this lecture. Thanks very much.